Hello everyone. Today we're going to talk about queue data structure. This tutorial is a part of the data structures and algorithm class. Queue data structure mimics a queue of things in real life. For example, a queue of people who's waiting in front of a restaurant, like you can see in this picture. Data in the queue, or in this particular example, the people, gets in and out follows the honor system. First in, first out, or FIFO. Queue data structure is a very popular data structure. One of the obvious applications is to mimic the real-life queue. For example, queue of people in this picture. Or to implement a message broker system which you use every day, like the one on iPhone iMessages, Android Messages, Slacks, Microsoft Teams, and so on. Another popular and important application is to implement the breadth-first search algorithm, which we will learn about it later. Queue data structure is a very simple and easy to understand data structure. It always has two main operations. The first one is enqueue and the second one is dequeue. Enqueue is to put the data element at the end of the queue. In this example, I enqueued 3 and 3 is appended to the end of the queue. Dequeue is to remove the first element of the queue, the one that comes first. In this example, I dequeue and element 1 got removed from the queue. With 1 removed, element 2 becomes the first in line. JavaScript doesn't have queue data structure built in, so we're gonna build our queue data structure. It's quite simple to do so. We create class queue, and we will use an array to keep track of the queue. With enqueue method, we push the data into our queue. This operation is O1. With dequeue method, we remove the first element in our queue, and because we're using the array to keep track of the queue, this operation is ON, but we can easily achieve O1 for this operation. You can try to do that later as a practice for your programming. We will also have some helper functions to give us some insight about our queue. Just like our stack data structure, the size method will give us the total number of elements in the queue. The pick method will give us the element in front of the queue. The print method will let us see all the data in the queue. All of these operations are in O1 complexity. Our queue data structure is done. Now we're gonna create a queue and we print it out. Of course, it's empty for now. Next, we learn how to do operations in our data. For queue, insert is enqueue. We enqueue 1, enqueue 2, enqueue 3. And if we print it out, we have 1, 2, 3, with 1 is the element in front of the queue. To delete, we have dequeue. Dequeue gonna give us the first element in the queue, and it will also remove this element from the queue. So if we print it out, we have 2, 3, with 2 is the element in front of the queue now. So then if we pick, it's gonna give us 2. And if we have a look at the size, our queue now had 2 elements, so size is 2. Next, we remember how fast these operations are. Queue operation has O1 in insert and delete. Inserts is enqueue and deletes is dequeue. Don't forget to implement the dequeue method with O1 complexity by yourself. Queue data structure doesn't have access or search operation, so the time complexity is not available. That is all for today's tutorial. Thank you for watching, and I will see you in the next video.